Good morning, everyone. This is Miss Landis here. Today we are starting topic 10, lesson 4, which is multiply a whole number by a mixed number. We're going to read the essential question and discuss, work on the convince me, and then work on page 563, numbers 1 through 4. Now, previously, we have been multiplying whole numbers by just fractions, but today we are starting to multiply whole numbers by a mixed number. So it'll have a whole number and a fraction part. So I'm going to be showing you guys the process and the steps involved to creating that equation and how to complete it using the distributive property. So first, we're going to start by looking at our essential question. So we did not have a solve and share for this one. We decided to get rid of some of the solve and shares just because they were taking up too many pages in the packet. So we are just going to start with reading our essential question, which is how can you multiply a whole number and a mixed number? Now, this is just day 1 of a 3-day lesson, so if you feel like you don't fully understand it today, that's okay, because there are 2 more days that I'll be making videos that have to do with 10-4. So you don't have to completely understand how to do it today. All right, how can you multiply a whole number and a mixed number? Ellie wants to make 5 blankets as gifts for her friends. It takes 2 2/3 yards of fabric to make each blanket. How many yards of fabric does Ellie need? So something that I kept saying in the previous lessons when we're multiplying fractions and whole numbers is to look for the fraction and how many times it's repeated. And that's a rule that you can use anytime you're creating a multiplication equation. If you see something that's the same, that's repeated over and over, think about how many times it's repeated, and that is how you can create your equation. So here she's using the same amount of fabric to make each blanket, which is 2 2/3 yards. And she's creating 5 blankets. So that's the amount that it's being repeated. In the diagram down here, the bar diagram, we can see that 2 2/3 being repeated 5 times. And Y is going to stand for yards, the total amount of yards that she's using for all 5 blankets. In a real world situation, this is an important question to be able to solve, because if you were doing something like knitting and you wanted to create 5 blankets, you would have to go to the store and know how much in total to buy to make sure that you had enough. We are going to focus just on this one way today, not the another way, because it shows 2 2/3 being changed to a fraction, and we haven't changed mixed numbers to fractions in our class, so disregard this one and focus on this one way. Now, I kind of worked through how they broke it down in this picture, but I'm going to break it down separately for you after I explain it. In the picture, they show 5 bar diagrams to represent the 5 blankets, and each of the bar diagrams has the 2, 1, 2, and 2/3 because they show 1/3 twice. So in the bar diagram, they have a visual representation of the problem. Our 2 equations that we'll be doing are 5 times 2, because there's 5 times the 2, the whole number, in 2/3, and then 5 times 2/3, because we have the fraction part being multiplied by the 5 as well. So I'm going to just move this to the side. And I would say just find a blank spot on your paper. It looks like there's kind of some room on the side, or you can use some of the space of the convince me because we won't be using the whole thing. but I'm just going to break that down a little bit more as to how we are going to be doing it, and just simplifying it into like a certain amount of steps that we'll do. As soon as I can find my expo marker. Okay. So if our equation is 5 times 2 and 2/3, we want to take that 5 and we want to multiply it by, I'm just going to move this down a little bit because I need some room up top. We want to take that 5 and we want to multiply it by the 2 and by the 2/3. So the 5 is going to be like that main number that we're using because 5 needs to be multiplied by 2 and 5 needs to be multiplied by 2/3. One major misconception that we might see sometimes is you want to take the whole numbers and multiply them together and just stick the fraction next to it. That's a no-no, because the fraction still needs to be multiplied by 5. So we'll be creating 2 separate equations and then joining them together at the end. And we'll talk about what property that is when you split numbers apart in order to multiply, because that is the property that we're using, and it will help us answer the convince me. So first, we're taking 5 times 2. And I think that the arrows help. That's why I'm showing you how to do it this way. But if this is confusing, there's other ways to do it as well. And me or Mrs. Capizzi would be happy to work with you and show you a different way if you feel like this is not working for you. But first, don't be discouraged. Give it a try for today and maybe tomorrow. And if you're still stuck, there's another way. There's a few other ways. So first we'll do 5 times 2, and I'm writing the whole thing out. That's my first equation. I'm using the parentheses in order to keep it separate from my next equation, which I will be adding when both equations are solved. Use the arrows to guide you. I did 5 times 2. My next parentheses are 5 times 2/3. And we're keeping the parentheses. The parentheses are here to separate from the plus sign. In the order of operations, which tells us that operations need to be done in a certain order, multiplication comes before addition. So first we would multiply 5 times 2 to give us 10, plus 5 times 2/3, whole number times numerator gives us 10/3. Now the next thing that I see that students want to do is do this. But you can't write it like that. We have to make the 10/3 into a mixed number before we can do anything else. So at this point you should be a little bit better in turning these into mixed numbers. Maybe on a separate spot, like not in this equation, like off to the side somewhere, you could do that. So I would take my 10/3 and break it apart, find how many wholes I can make, equals 3/3 plus, and I'm already thinking I know 3 times 3 is 9. And I'm going to have 1/3 left over. So that's 1, 2, 3 wholes with 1/3 left over. So now my 10/3 would become 3 1/3. Let me just push this up a little bit. So then I would have 10 from my 5 times 2 plus 3 1/3 from my 5 times 2/3. And my final answer would be 13 1/3 yards. And in looking at the work shown here, we have all of the same information going on. We have the same equations in the parentheses, 5 times 2 plus 5 times 2/3, which ultimately gives us 10 plus 10/3. Change the fraction to a mixed number, and 13 1/3 is our answer. Looking at the convince me, the convince me says use structure. In the example above, what property of operations is shown by the fraction strips? Explain how the model shows the property. Just going to move that to the side for a second, and you might even forget what properties of operations are, and that's okay, because I don't think that you're sitting at home thinking about the properties of operations while all of this is going on, because I know I'm not. But the properties of operations, there are properties of operations for addition and for multiplication, and they're kind of different, just not rules, but certain ways that we can multiply or add following a specific structure. So, for example, I feel like the one that most people remember all the time is the, can't forget how to spell, Miss Landis, commutative property, which says that it works for addition or subtraction, is that we can multiply in any order and still get the same answer. So 10 times 5 is going to be the same answer as 5 times 10. They're 50. Because it doesn't really matter the order that you multiply numbers in, you'll still get the same answer, which does work for multiplying a fraction. If you are doing 4 times 1/4, you're going to get 4/4, which is equal to 1. And that's the same as switching around the 2 and saying 1/4 times 4. It's still going to give you the same answer. You can switch the factors and you'll still get the same product. The commutative property is not exactly what we're using to solve these types of problems. The commutative property does come into play because when you form your equation, you can put the whole number or the mixed number first. It really doesn't matter. The property that we will be using is the distributive property. There's also the associative property. The associative property says that we can group together numbers differently when we're adding or subtracting, but today really what we're focusing on is breaking apart. So the distributive property is the property that is about breaking apart numbers. And one way that we are familiar with the distributive property is when we multiply using the box method. So if you are multiplying like 25 times 16, one way that you could use the distributive property is by breaking those numbers apart to multiply them. If we broke apart 25, it would be 20 plus 5. Breaking apart 16, it would be 10 plus 6. We are breaking apart numbers to multiply. So we're taking the 25 and we're breaking it apart into 2 pieces. We're breaking the 16 apart into 2 pieces in order to solve an equation. The way that we will be using the distributive property for this type of problem is we are looking at the mixed number and breaking it apart. So if our equation was 4 times 1 and 2/8, the mixed number is what we're breaking apart. We would be multiplying the 4 times 1 and multiplying 4 times 2/8 separately. So our equation would end up being 4 times 1 plus 4 times 2/8. Solve for both. So 4 times 1 is 4 plus 4 times 2 is 8 eighths, which 8/8 is equal to 1. So our equation would, I'll just kind of continue this up here, would end up being 4 plus 1 and equal to 5. Now, I went through that very quickly because I was just showing you the breaking apart, but I will be doing it a little bit slower in our other examples. So let's write something for the convince me. So in the example above, what property of operations is shown? The property is the distributive property. Explain how the model shows the property. So in looking at the model, we can see the 2 being broken off from the 2/3. We see those 2 separate equations. So let's answer each part separately. So the property shown is, okay, let's zoom that a little bit. The property shown is the distributive property. The model shows the mixed number broken apart into 2 and 2/3. So take a moment and copy that, and we will be working on page 563, number 1, 2, 3, and 4. Your page doesn't give you like a tremendous amount of space to show your work, unfortunately. I am going to be doing the work on my whiteboard. If you have scrap paper at home and you feel like you need more space, I mean, I am somebody who can write small. Like, I could write small and show the work on here, but for the sake of you, I want to write bigger, so I'm doing it on the whiteboard. If you write small enough to fit it on here, that's cool, but if not, then maybe find a piece of scrap paper. That way you have the space that you need for these types of problems. Alrighty, starting with number 1. In the problem on the previous page, how much fabric would Ellie need if she wanted to make 5 blankets? So we are extending that equation to, instead of 2 and 2/3 times 5, now we would have 2 and 2/3 times 6. And I'm going to be using the commutative property when I write it on my whiteboard because I would rather write 6 times 2 and 2/3 to follow the structure of kind of how I've been showing the equation. So let me, there we go. So the commutative property says that we can switch around the numbers that we're multiplying and we will still get the same answer. So I can write 6 times 2/3. 6 times 2 and 2/3. And it's the same thing. I like to write the whole number first because then we can draw the arrows indicating the 2 equations that we're making. So first arrow goes to the whole number, and our first equation is 6 times 2. And then our next arrow goes to the fraction, and we'll be adding the answer for 6 times 2/3. So you should have 2 separate equations here that you will be adding the answers together to for your final answer. 6 times 2 needs to be in parentheses. 6 times the fraction of 2/3 needs to be in parentheses. And then we can start to solve. So 6 times 2 is 12 plus whole number times the numerator. 6 times 2 is 12 over our denominator of 3. And we have to turn that into a mixed number. So somewhere off to the side somewhere, I can do that work separate. 12/3 equals how many 3/3 can I make until my numerators add up to 12, or as close as I can get to 12 without going over. I have 1, 2, 3, 4 holes that I can make because 3, 6, 9, 12. So 12/3 is equal to 4. So it becomes 12 plus 4, which equals 16 yards. And that is my answer to number 1. So I'm just showing all of my work on the whiteboard. If you feel like I'm going too fast, there is a way to slow down the video on YouTube. If you click in the bottom right corner, you can slow it down, or you can pause it at certain spots. Like if I'm moving too fast, you can pause it here to copy this. 2 2/3 times 6 equals 16 yards. Make sure you have the label on your answer. Next, for number 2, find 3 times 1 3/3 using the 2 methods shown on the previous page. Sorry, I'm making the executive decision to just say find the answer. We don't need to find it 2 different ways. We're just going to find it one way. Find 3 1/3 times 1 1/3. That's a complicated enough question as it is. I'm not going to make you find it in 2 different ways. So just solve the equation, people. All right, 3 times 1 1/3. So we know we're going to be doing 3 times 1 and 3 times 1/3. 3 times 1 in parentheses plus 3 times 1/3. And with problems like these, the more repetition you see, the easier it's going to get, because you start to understand the process and how to break it down using the distributive property. And then the hardest part will really just be probably turning your fraction into a mixed number, because I feel like that's kind of the hardest part that a lot of us struggle with, which is okay because it's a hard concept. 3 times 1 is 3 plus 3 times 1/3, whole number times the numerator. So 3 times 1 is 3 over 3. That's easy. That's equal to 1, right? So we'll end up with 3 plus 1, which equals 4. And like I said, if I'm moving too fast, you can pause it here and finish copying, but I'm going to move on and write my answer and rewrite the equation. 3 times 1 1/3 equals 4. And there's no label. Moving on to number 3, I'm going to rewrite it on my whiteboard. 2 times 2 1/4. Get my arrows going, my whole number, and make sure something that people might do is write this like this, which is okay because the commutative property tells us we're going to get the same answer, but when you go to draw your arrows, you're going to run into a problem because the fraction is over here. So that's why I've been setting it up all the time with the whole number first and then the mixed number. So arrow to the whole number, that means that we'll be doing 2 times 2 plus arrow to the fraction, that means we'll be doing 2 times 1/4. All right, so first solve for 2 times 2, which equals 4, plus 2 times 1/4, whole number times the numerator over the denominator. And look at that. We don't even have to do any more work because the numerator is less than the denominator, so we got lucky on that one. Our answer, we just stick them together. When you see whole number plus a fraction, you just stick them together like they're glued there. And 4 2/4 is our answer for number 3. So like I said, if you want to pause here and copy the work, if I'm moving too fast, I am going to go ahead and just write 4 2/4. And if you're doing what I'm doing here, you still have to have the work somewhere, whether it's on a separate page or on the sides of this page, or you're able to squeeze it in here. There's a little bit more space under number 4, so you probably have room to squeeze it there, but I recommend a separate piece of paper. We have one more to do together, which is number 4, 2 times 1 1/2. 2 times 1 1/2. 2 times 1 1/2. Arrows. We know our first equation is 2 times 1 plus our answer for 2 times 1/2. I know 2 halves make a whole. 2 times 1 is 2 plus 2 times 1/2. That should be easy. 2 halves make a whole. So if I have a cookie and I split it in half and I give the other half to somebody else, our 2 halves, if we put them together, they should still make a whole cookie, right? So 2 times 1/2 is going to be 2 halves, or 1. 2 plus 1, which will give us 3. And I am going to write on my paper equals 3. And you can even look at the pictures too, like this is one whole, this is one whole, half and half would make another whole. Like if you brought this piece up here, it would fill in that spot to give you another whole. So that completes our work for day 2 of the week 5 and on contingency plans. Tomorrow and the next day, we are still working in topic 10.4. So if this feels like it was a lot for you, it's going to be okay because we have 2 more days of it. Reach out if you need anything. And once again, we miss you guys, and we hopefully will be able to go over all of this when we're back in class together. Have a wonderful day, and we'll see you guys soon.